let's dive deeper into that, in fact. Okay, so we're given an array of integers and we want to remove each kth element from it. So what do we mean by that? Well, if k was 4, let's say, then we'd be talking about each fourth element. So element 4, element 8, element 12. Basically what they mean, okay, if I want to put this into more formalized terms, what they're trying to say is we want to take this array and we want to remove every element whose one-based index is divisible by k. In other words, the index is a multiple of k. So if k is 3, we're looking at 3, 6, 9, 12, etc. All right, so there was one thing I mentioned in there that I want to make sure it doesn't, slip past anyone. I said the one-based index, and that's going to be sort of important for this particular problem. Notice when they say each kth element, so like each third element in this case, they're saying 1, 2, 3, cut this out. So like, get rid of the 3, 4, 5, 6, cut this out, 7, 8, 9, cut this out. So it's a one-based index, and the reason I'm making kind of a big deal about that is because by default, arrays in JavaScript, and I think pretty much in all languages, are zero-based. They normally start with an index of 0, which you probably know if you've made it this far in the video series, but hey, it doesn't hurt to state the obvious sometimes. Okay, so another way we could look at it is, it's kind of interesting because this is actually just as good of a description of the problem as this is up here. So it's saying the output should be input array, except without the elements k minus 1, 2k minus 1, 3k minus 1, etc. And keep in mind, those are the indices. Now, they happen to be the elements themselves in this particular example, but in other examples, they will not be. So like for this one, this is the first element, this is element 2, element 3, etc. Okay, so we'll look at those in just a sec, but before we do, I want to talk about this stuff here. So we've got k minus 1, 2k minus 1, 3k minus 1. So basically what we're saying is we want the index I to be equal to k minus 1, or we want the index I to be equal to 2k minus 1, or we want the index I to be equal to 3k minus 1. Okay, so there are a few ways we could look at this, but the main thing is I'm looking at this, I'm seeing the k here. So we've got 1k, we've got 2k's, we've got 3k's. That's probably the part that I want to isolate here. So I'm going to say I plus 1, I'm going to add 1 to both sides. I plus 1 is equal to k. That's an equivalent statement to this one up top here, or on the left, I should say. I plus 1 is equal to 2k. Or equivalently to this one, I plus 1 is going to be equal to 3k. Okay, neat. Okay, so that's good. Basically what we're noticing here is that I plus 1 is the thing that's going to be a multiple of k. So what we can take away from this, and I'll use a nice striking color and a thicker pen here. What we can say is I plus 1 is going to be a multiple of k. All right, so in other words, if we were to divide this by k, in this case we get 3, but the main thing is that there would be no remainder. In this case we get 2, no remainder. In this case we get 1, no remainder. So when we divide I plus 1 by k, we get a remainder of 0. So we'll use our modulus operator here and we'll say I plus 1 mod k is going to be equal to 0. So this is probably the main thing we're going to be using here. This is a piece of information that will probably follow us into our algorithm. And I guess on that note, we might as well redirect our attention to that algorithm and actually write the thing. So basically what we want to check is if our index plus 1 mod k is 0, right? That's what it said. Index plus 1 mod k is 0. Okay, great. So why don't we start by doing something like this? Let's just go through all the possible indices. So we'll go from 0 to input array dot length, and then I plus plus. By the way, common mistake is to forget the dot length. I've probably done that about a half dozen times on stream already, so always remember that. Okay, so I goes from 0 to input array.length. So it's basically covering all the indices. And what we want to say is if I plus 1 mod k equals 0, then something. We're going to do something special in that case. So maybe we'll just do something like, here, I'll do a console.log of input array at I, so the actual element there, and then we'll return just input array for now. And we'll take a look at our console log. So basically for this one, we're saying, yeah, 3, 6, and 9, those are the ones that we want to cut out from here. Okay, that's good. And for the next one, well, this is every one element, so we want to cut out every one of them. For this next one, every second element, so we'll take out basically all the 2s. We're going to be left with just the 1s here. Okay, cool. So then let's actually do that, I guess, right? So we could do something like this. In the past, we've done splice in order to take out an element. So remember, splice is going to take, well, it can take a number of arguments. In this case, we'll use a few of them. We're going to say that we want it to start, the thing that we're going to take out, we're going to start at index I. How many elements do we want to take out? Well, we just want to take out 1. And do we want to replace it with anything? No, we don't want to replace it with anything. So I'm not actually going to put anything into that last part there. All right, and now the thing about splice is it is a mutating method, so it's actually going to change input array. So basically, you know, if I were to say like let A be assigned the value of this, well then in that case, A would be like the thing we're taking out. It would be like an array containing just the element that we're removing. So that's not really what we want to be doing, but maybe just for fun, let's console log this thing so we can see what it's actually taking out and see how that compares to what's left over. And now I'm just returning input array because splice, like I said, it's a mutating method. It will change input array, unlike something like a slice, which will leave input array intact but make a new copy with some different properties, like not all the elements. Okay, so we'll give this a run, and it's not right. Okay, so let's analyze this. I'm going to make that a little bit bigger. It's taking out 3, which is good, but then it's taking out 7, which is not so good. So let's investigate. I'll make this a little bit thinner, and there we go. So if we're going through these, if we want to take a look at our indices, like, I mean, they start out as being the same as the actual elements in this one, which is kind of convenient, I guess. But basically what's happening is we're going through this and we're saying, okay, 1, 2, 3. Okay, this one's divisible by 3, so we're going to cut that one out. The thing is, we're actually splicing it, right? So we're actually removing that element, like we're getting rid of it. So when we get rid of it, of course, we get rid of the index as well, which means all these indices are wrong now. They should actually be like 3, 4, 5, 6. So now it's going through and it's seeing the next element that's divisible by 3, which would be 6, or the next index, I should say, which is divisible by 3, which would be 6. And so it cuts out the element with index 6. But now that's 7 because it got shifted over. So it's not really what we're looking for. And then the next time, like after that, the thing that it would want to take out would actually be beyond the scope of the array here. So it's not going to work out. Okay, so maybe there's a way around this. Maybe there's a way we can modify splice in order to prevent this kind of behavior. But actually, I feel like I kind of don't want to use splice because every time we use it, we're sort of like, you know, we're going through the array, we're modifying it. I feel like just in terms of computation time, maybe there's a better way we can do this. So basically what we want to do is something like this, right? Input array at I, we want to mark it down as being like, no good. We want to take that part out. All right, so we want something sort of like this, except we don't actually want the x's to appear in there. If these x's weren't there, then we'd be all good. You know, 1, 2, 4, 5, 7, 8, 9. It's the same as what we have down here. So luckily, we have a built-in for that. It's one we've seen before. It's filter. So we're going to filter this, okay? So we're going to say filter, and remember, filter, we can either take like one element and just say x, and you know, if x equals x, do something. Actually, that's kind of confusing. Maybe I should have used the word element, but our other option would be to take both of these to take the element itself and the index at which it's occurring. Now, in this case, we've already sort of identified some business about the indices, so we can afford to basically just cut out the x's. So we don't need to know what the what the index is. We just need to know what the element is going to be. And if the element is not equal to the capital letter X, we'll keep it in the array. And I'm just using X arbitrarily here, you know, like we could have used anything. It's up to you, whatever you want to use there. I'm just using X as kind of like, I don't know, something that wouldn't be mistaken for a number. Okay, great. So that seems to be working. It's cutting out all the X's. It's getting the right arrays. It's filtering out all the ones that we want to remove. So the way I sort of think about this algorithm is basically, and I'll just do a little console log of what the input array looks like just before we run this filter at the end here. So basically, yeah, this is what it's looking like. The way I sort of look at this is it's kind of like we've got a city worker, you know, when you see them going by and like spray painting trees, like putting a big X on it or something like that, and then later someone will go and cut those down. So basically, this is the same sort of thing. We're marking all the elements we want to remove, and then we're just filtering them out at the end and yeah, chopping down them trees. Okay, great. So that's working. It's passing all the visible tests. Will it pass the hidden ones? Let's find out. So we're going to run this. We're going to see what happens with it. And hopefully we see some kind of success thing popping up. This is making me so nervous right now. I guess this is a time of day where there's a lot of users online. So, oh, there we go. Okay, so great. 25% of the way through diving deeper, but we're not quite done with this one yet. We're gonna, oh, hey, look at that. Our programming skills are impressive. So companies like Uber, Dropbox, Asana, and Quora are using codefights to find talented engineers. Create your profile to get started. You know what? I'm gonna not do that right now, but I am flattered. So thank you for that. And I mean, look at this. This is, okay. Look, I came from a time growing up when the dominant mentality was that like games, video games, that sort of thing, were a waste of time. You know, you're just wasting your time, wasting your energy. And I think it's just beautiful that now we live in a world where we have these gamified apps where we can come on here and just have fun and at the same time learn something. And at the same time as that, develop opportunities like this, you know, to be able to have job offers and that sort of thing. Just from doing something that's fun, enjoyable, that you love. I mean, that's a beautiful thing. I mean, that's the sort of, that's like a utopian element of our modern reality. So you got to give thanks. Anyway, not right now. Oh, and look at this. Wow, this is a lot of big news happening today. So we made it to a new level. Wow, we're a trainee now. What an honor. Okay, so we'll close that for now. And, okay, so this was passing all the tests, but could it be better is the question. And yeah, I think so. So one of the things you might notice is we're basically going through every index, but then only looking at the ones that have this property. But we kind of already know which ones are going to have that property. It's the ones with elements k-1, 2k-1, 3k-1, etc. So maybe we can rework this somewhat. So instead of going through all the indices, let's say maybe something like let like multiple or something, multiplier. Maybe that's too long, but we'll see. We're going to let multiplier be assigned the value of 1. And we're going to go until k times multiplier minus 1. We'll continue while that's still less than input array dot length. And then we'll do a multiplier plus plus. So I don't really like the way that's splitting onto the next line. Maybe we'll just do this for now. But yeah, maybe multiplier is too long as a variable name. I guess we could always just like split these up, right? We could do something like that. It's kind of an awkward way to look at a for loop, but maybe it's not as awkward as what we had before, to be honest. So, okay, I'll leave it like that for now. So we're identifying this new variable. It's called multiplier. We're saying k times multiplier minus 1 is less than input array dot length. And why this? Well, this is the index that we're going to be using, right? K times the multiplier minus 1. So multiplier is like the 2 here, the 3 here, the invisible 1 over here in front of the k. So that's what multiplier is doing. So 1 times k minus 1, we'll look at that. 2 times k minus 1, is that still, within range? 3 times k minus 1, we'll do that until we get to 1 that's out of our range that we're looking for here. And then basically, since we know that we're using the right indices, we don't need to do any checking. We don't need to do like this if at the top here. All we really need to do is something like this, except what's I? Well, I is going to be this. It's our index. It's going to be k times multiplier minus 1. And technically, we could even say, like, we could do a little assignment operator here, and I is assign the value of this, but I don't know. I'm not too dismayed about the fact that we're repeating a calculation here. Okay, so actually what I should have done is maybe something like this and just archive this solution and then brought this up over here. And so now we have two ways of looking at it. We've got the way that's going through every index and seeing if it's the type of index that we're looking for and then modifying it if it is, versus this one, which doesn't look at every index. It only looks at the ones that we know are the right type of index for what we're trying to do, and then making the modification to each of those. So let's run the tests on those ones, or on this one, and we'll see if that still works. That still works. Okay, so that's pretty cool. I mean, I would say that this one is like slightly more efficient. So I'll make a note about that. Slightly more efficient than the one below. Doesn't look at all the indices, just the ones we're looking for. Okay, great. So that should be nice and descriptive to the reader. Okay, so now let's say, maybe you're looking at this and you're thinking, okay, but like you're doing a filter on this thing, right? Do we really have to do a loop if we're already doing a filter? That's kind of like, feels almost like we're mashing up different paradigms there. So let's try doing this with like just the filter, so we'll do something like, okay, we'll do a filter now. So we'll do an input array dot filter, and now we'll do one that does take both the element itself and the index of that element. Okay, so we're going to be looking at both of those things. And basically what it's going to say is, hey, if your index plus 1 mod k is equal to 0, then you shouldn't stay. So those are the ones that we want to not stay. So to flip this around, let's say, well, actually, let's run this and we'll see what we get. We get nothing because I didn't put return. So let's try this and we'll see what we get from this. And I'm thinking, yeah, it's just going to be the elements we want to take out. So instead, we won't say equals 0, we'll say not equals 0. So the ones that aren't 0, let's keep those. Okay, great. So, well, that's pretty nice. That's, I think in terms of how that looks a lot more efficient than both the ones downstairs. But there's one more thing we can do with it. I mean, check this out over here. We're basically saying this thing over here, if it's 0, I want you to return false. If it's not 0, I want you to return true. But that sounds kind of familiar. That's the default behavior for JavaScript. I mean, if it finds a number and it's trying to typecast it into a boolean, like in a filter situation where we're expected to return boolean. So if it's going to typecast this thing to a boolean, well, if it's 0, it'll typecast that to false. If it's 1 or anything other than 0, it'll typecast it to true. So we don't actually need this part in JavaScript, because if this is 0, well, that's false anyway, according to JavaScript. Keep in mind, not every language is like that, okay? So the one that I'm familiar with, I'm pretty sure in Ruby, a 0 or any number is considered true, okay? Even 0 will typecast to true in a language like Ruby. I'm not sure about a lot of other languages, but I know in JavaScript, 0 is false. In Ruby, 0 is true. So that's something to definitely watch out for. You wouldn't be able to use this algorithm without the this part at the end if we were doing Ruby here. Okay. Plus, it would probably look a lot different anyway. The point is this going to pass all the hidden tests? Let's find out. So let's give that a proper run here, and we'll see what happens. Okay, great. So that one's correct. I mean, that didn't take too long. We've got basically 3 versions of our algorithm here. And let's see. Yeah, I think that's pretty good. I mean, if we wanted to do it differently, like we could make this a little bit different, you know, like we could go back to this one. Instead of saying element is not equal to X, we could say something like, you know, type of element equals number, but not that much different. I think it's probably easier to just compare it to X because that's a little more explicit. Okay, so I'd say that's pretty good. I like the fact that we were able to get it down to just one filter. I probably would say that this is the best way to do it, using the filter method. Correct me if I'm wrong, if anyone knows, but I kind of figured, like, in terms of time complexity, look, you've got a filter down here anyway. Doesn't this thing need to go through the whole array in order to do its filtering thing? So might as well just do that without having the loop before it. That's how I feel anyway. Okay, so if you want to take a more detailed look at this, it's solution number 3677, just below the Metroid. All right. Let's move on from here, I guess, unless anyone has any questions, comments, or concerns. Let me know in the chat.